All right. Welcome, everybody, to the fourth virtual Teen Science Cafe of the year. Before I get going in my spiel, let me just introduce you all. Probably know Tamara and Riley by this point, but go ahead and wave. Um, so, yeah, thanks. Before we get started, I do have one suggestion to get you all out of the house because I know everybody's probably got a little screen fatigue by this point. I was helping one of our other educators with an activity that she developed for some younger kids, but I went outside and I enjoyed it immensely. It's just a nature scavenger hunt about like going out and finding specific plants and like different types of leaves. So it's like it really just had me out looking really closely at nature around me. Like I saw a snake, I saw these weird little pods, I saw like fungus and all kinds of stuff. So it really just like gave me something to do while I was outside taking the breeze. So if you're interested in that document, go ahead and shoot me an email, and which I'll put in the chat function here in just a moment. And I'll send it to you because it's actually a lot of fun, especially you have like younger siblings who are driving you nuts and you just want to kind of get them out and running around. Then it's a great way to just spend the morning or afternoon or whatever. So without further ado, I will let Riley introduce our speaker. So Riley, go ahead, and I'm going to disappear for a little while because I know you're tired of looking at my old mug.
Okay, so today we have Lauren McRae, who's a PhD candidate in the Department of Chemistry Materials Division here at Chapel Hill, UNC Chapel Hill. Her research involves computationally and experimentally exploring materials that have applications in electric vehicle batteries. She'll be talking about how climate scientists plan on tackling climate change over the next decade. And without further ado, I'll let Lauren take it from here.
Thanks, Riley, for the introduction. I'm going to go ahead and share my screen. So today I'm going to be discussing climate change and some of the work that my colleagues and I at UNC are doing in order to reduce our impact on climate change. Now, before I begin, I want to tell you that I myself am a chemist and I'm not a climate scientist. So although I will talk about some things that are related to climate change and give you an intro as to what climate change is and some of the issues we are facing with it, that's not my area of expertise. And so I wanted to begin by talking about the definition of climate change. And this is a change in global or regional climate patterns, in particular, a change apparent from the mid to late 20th century onwards that is attributed largely to increased levels of atmospheric carbon dioxide produced by the use of fossil fuels. So when we think about our impact on climate change, a good way of quantifying our impact is by seeing how much greenhouse gas we're emitting through different sectors of our economy. And so the US is a very large contributor to climate change in that it's the second largest greenhouse gas emitter internationally. China is the largest, and the US in 2018 produced over 6,500 megatons of carbon dioxide. Now, if we compare this to something more tangible, this is equal to the weight of over 131 million elephants. So it's a ton of carbon dioxide that we're producing each year. And gross US emissions have increased a little less than 4% since 1990. So along with producing lots of carbon dioxide, we are also increasing the amount that we're producing each year. And so to figure out ways to decrease these emissions, we need to think about which sectors of the economy are most influencing this greenhouse gas emission. And so I have shown here a pie chart that breaks down the 5 different sectors that are contributing largely to these greenhouse gas emissions. The first is electricity, and this is the generation and transmission of electricity, which primarily happens in power plants. The second is industry, in which you're producing goods. The third is transportation, in which you're moving goods and people from one place to another. And this is actually the largest sector of greenhouse gas emissions. The fourth is commercial and residential powering. So any building that you reside in or work in, it falls under this category. And then lastly is agriculture. So in my presentation today, I'm going to focus on the two largest greenhouse gas emission sectors, electricity and transportation, and some of the ways that we're trying to reduce the greenhouse gas emissions in these sectors by using the knowledge that we gained from research. And so the electricity sector involves the generation, transmission, and distribution of electricity. And if we break this down further, we can see that the majority of electricity that's generated is generated from non-renewable resources. So this includes coal, which makes up 28%, natural gas, which makes up 34%, and then a small amount of petroleum. Now, natural gas is a cleaner method of electricity generation than coal in that it produces 50 to 60% less carbon dioxide than coal burning does. However, it's still not a completely clean way of producing electricity. The cleaner ways and the ones that are made from renewable sources are nuclear, which makes up 20%, and then various renewable sources that I'll talk about. And so today I'm going to focus on what scientists are doing to improve the available renewable sources for energy generation. And so if we break down the renewable sources in this electricity sector, there are four main ways that we can generate electricity. Hydropower is the first, in which you harness the energy from moving water in a river by damming it, and then you harness that with a power plant. And so the advantages of this type of electricity generation are that it's reliable. So there's very little fluctuation in the electric power being generated as long as there's water available in the river. It's flexible in that you can change the amount of water that's coming in through the dam, and subsequently you can change the amount of electricity that's output from this. And lastly, it's safe. When you compare using water to generate electricity to the burning of fossil fuels, it's a lot safer. But there are a couple of disadvantages with this type of electricity generation. There are environmental consequences. There are species that live in and around the river that are affected when you dam the river. And so they're affected by water levels, the velocity of the water, and the availability of food in and along the river. So if they're not able to move in certain places of the river because of a dam, they'll also be affected in that way. Your electricity generation is also affected by droughts. So if you have less water available to make electricity, your price of electricity will go up. And lastly, you have limited reservoirs in which you can build a dam and a power plant. And so because of this, you have a limited amount of electricity you can get out of this type of electricity generation. The second I'll talk about is biomass, which is the burning of organic solids to make energy. And so the advantages of this type of electricity generation is that it's less expensive than fossil fuels. And when you're burning organic solids, you're actually able to reduce the amount of garbage in landfills by about 60 to 90%, which is a positive. The disadvantages include that it's less efficient than fossil fuels, so you have to burn more biomass to get the same amount of energy that you get out of burning fossil fuels. It's not entirely clean, so although you don't get carbon dioxide from burning biomass, you can get methane gas, which is another type of greenhouse gas. And lastly, because most of the biomass that is used for electricity generation is wood, if we were to rely heavily on biomass for electricity generation, it could lead to deforestation when we need to scale up the amount of wood that we have available. The next one I want to talk about is wind energy. And so the advantages of this type of electricity generation are that it's cost effective. So wind is a free source of electricity, or a free source of fuel, and you can use it anywhere and anytime. It's safe, and so again, if you compare to the burning of fossil fuels, using wind is a much safer method of electricity generation. And installation of these wind turbines can happen on existing land. So they only take up a fraction of farmland if you were to install them there. And you can also install them out in the ocean where there's not going to be any people in the way. And so The disadvantages of this type of electricity generation is that wind fluctuates. And so you're not going to have electricity from this type of electricity generation all the time, because sometimes it's very windy and sometimes it's not. The wind turbines tend to cause noise and aesthetic pollution. One wind turbine can be heard up to 100 miles away. And so that can be very disturbing for the communities surrounding wherever you decide to put the wind turbines. And also they're quite large. And so aesthetically, they're not particularly pleasing. They also are a threat to wildlife. So if birds run into wind turbines, they can be killed by them, which is not ideal for any ecosystems surrounding the wind turbines. Lastly, we'll talk about solar energy, which comes from harnessing the light from the sun to turn into energy. And so the advantages of solar cells is that they can be installed in many places currently. They can be installed on the roofs of buildings. They can also be installed out in fields. Again, this type of electricity generation is safe because you're not burning any type of fuel. And the efficiency of the solar cells is able to improve as we improve the technology. So that's another advantage. The disadvantages of this type of electricity generation is that the sun is not a constant source of energy. So sometimes you'll have sun and sometimes it'll be cloudy, and on cloudy days you get less electricity. You obviously don't get any electricity at night because there's no solar energy then. And also during the winter, you're gonna, as a whole, get less electricity generation because the days are much shorter, so you don't have as much daylight to harness. And also solar cells tend to have an initial high cost for installation. And so this will deter people from installing them because they don't have the money or the will to do that. And so the kind of link of all of these is that they are not constant sources of electricity. There's going to be times when there's more electricity available and times when there's less. And so if we're able to store the excess electricity in some type of battery, we can use that energy at other times when we don't have the electricity being generated from our source of energy. And so to make this technology universally accessible, we need to make high capacity batteries. Now, before I go into talking more about batteries, I want to give a little bit more motivation for trying to find high capacity batteries. And by doing that, I'm going to start by talking about the transportation sector. And as I've discussed before, this includes the movement of people and goods in vehicles. And so currently, most vehicles are powered by a combustion engine. Combustion engines are fueled by hydrocarbon oil, which is combined with oxygen in the air and a spark. And this creates heat, which can be used as energy to power the vehicle that it's in. Now, this reaction also involves the making of carbon dioxide, which, as we've discussed, is a greenhouse gas. So this is not an ideal situation for trying to power a vehicle. So scientists are considering other methods for powering vehicles. And the two things that really have been explored recently are switching fuel types. So instead of using this hydrocarbon fuel, they're exploring water or using hydrogen and other types of fuel. And there's also, people are considering switching to fuel efficient vehicles, which include hybrid and electric vehicles. And these vehicles are powered by batteries. And so in order to scale these fuel efficient vehicles and make them more universally accessible, we again need to find batteries that work well in this type of technology. So that's really what my research has been focused on at UNC Chapel Hill. And so we know that lithium-ion batteries are currently the gold standard for technology. You have lithium-ion batteries in your phone, in your laptop, and really any number of technologies that you use on a day-to-day basis. And so people have been looking at applying electric vehicles to these bigger applying lithium-ion batteries to these bigger technologies like electric vehicles, and for storing other renewable source energy like solar energy and wind energy. However, if we think about how a lithium-ion battery works, we find that there are a couple disadvantages that come with applying these batteries in larger technologies. So this is a schematic of a lithium-ion battery. Commercial batteries tend to have a graphite anode, which graphite is just layers of carbon atoms. And then we have lithium atoms intercalated or present between the layers of graphite. And so what happens when you use or discharge the battery is the lithium will lose an electron to the electric circuit, and the lithium ion will now deintercalate or move out of the graphite lattice into the electrolyte and into the cobalt oxide lattice, which is the cathode of this battery. The lattice itself will gain an electron, and the lithium, so that it can offset the positively charged lithium ion that is now intercalated within the layers. And so this battery, we say it's working via an intercalation mechanism because lithium ions are present between layers of either the graphite or the cobalt oxide. And this gives it a few advantages and why it's used for many smaller technologies, because these electrodes, because they're not changing volume much and there's not a lot of change between the two states, you're actually able to get very little degradation from many cycles of these batteries. So that's why the battery life is fairly long. However, there's few disadvantages when trying to apply these to larger technologies. This includes charge time. So large lithium ion batteries take on the order of 10 to 12 hours to charge. And if we're thinking about applying this to, say, an electric vehicle, if you compare that to a combustion engine, which takes minutes to fuel, it's really not a good comparison, and we need to decrease that charge time in order to make it more universally accessible. Also, the charge capacity is not high enough in order to allow the vehicles to move far enough or to store enough energy from the renewable sources to make it good enough to scale this type of technology. So if we think about this in terms of electric vehicles, the best electric vehicles can go about 250 miles right now on a charge. And on a day-to-day basis, that's okay. But for longer trips, people want to be able to go further without having to wait 10 to 12 hours to charge their battery. So we need to increase this charge capacity in order to make this more universally accessible. Also, lithium ion batteries are made out of very toxic waste. They cost a lot to make, and the resources that they're made out of are quite scarce. And so with all of these in mind, scientists have been exploring other technologies, other batteries that could potentially be applied to these technologies. And so the first thing that they've really focused on is improving this lithium electrochemical system using lithium air and lithium sulfur batteries. And so the advantage of these types of batteries is that they have a higher capacity than lithium ion batteries due to more reactions, these multi-electron reactions that are happening at the cathode. However, they have lithium anodes, which tend to have a poor life cycle and safety concerns. So those need to be overcome before these types of batteries can actually be applied in these applications. There's been some other focus on other cation electrochemical systems, and so sodium batteries have been explored. Sodium, if you know, is one row down on the periodic table from lithium. So it has the same +1 charge when it's in its ionized form, but is a little bit heavier than lithium. And so the advantage of these types of batteries are that they have a similar capacity to lithium ion batteries, but they have a much lower cost and they're much safer than lithium ion batteries. But the disadvantage is that because the sodium ion is much more massive than a lithium ion, it requires a higher voltage to charge this battery. And magnesium ion batteries, so magnesium is one column over from sodium on the periodic table. So this means that it has twice the capacity because its charge, rather than being +1, it's +2, and so that means that it can shuttle 2 electrons per formula unit, which increases the capacity by quite a lot. However, because again, it's much more massive than a lithium ion, it has very poor ion mobility and increases the required voltage in order to charge this battery. The last thing that scientists have been focused on are anion electrochemical systems, which is what my research has really centered around, and trying to find the feasibility or see the feasibility of fluoride and chloride ion batteries. And these types of batteries have not been well explored. They've really come on in the last 5 to 10 years. when we're trying to really apply these to these larger technologies. And so fluoride ion batteries were first patented in 2010 and demonstrated in 2011. And they had to be run at high temperatures up until recently, because there was no known liquid electrolyte that could shuttle fluoride ions between electrodes. However, in 2018, the Honda Research Institute discovered this liquid electrolyte that could shuttle these fluoride ions at room temperature, and made the feasibility of these batteries much higher. And so now we've been exploring different electrodes that could be used in these batteries. And so if we compare the mechanism of fluoride ion batteries to the mechanism of lithium ion batteries that we discussed before, they work similarly, except instead of the ion that's moving, changing oxidation state between the two electrodes, you actually get the fluoride ion staying the same -1 oxidation state throughout, and you get a change at each electrode and a change in oxidation state at each electrode. So you tend to have some metal electrodes. In this case, I have shown a copper 2 fluoride cathode and a magnesium anode. And what will happen is when the fluoride gains an electron from the electric circuit when the battery is being discharged, it'll gain the electron from the magnesium metal, and it will then undergo a conversion reaction to move out of the lattice. And then when it moves into this lattice, it will undergo another conversion. The lattice itself will undergo another conversion reaction. And so instead of this intercalation mechanism, we have this conversion reaction mechanism, which tends to degrade the electrodes of this battery by quite a lot. And so in my lab, we've been focused on trying to find electrodes that work similarly to the lithium ion electrodes, in that they have an intercalation mechanism rather than a conversion mechanism. And so the biggest problem right now is the cyclability of these electrodes. But these are some of the problems that scientists have been faced, and some of the ones that we're trying to overcome within the next few years. But the conclusion here is really that I've only begun to scratch the surface of the methods that scientists are using to reduce greenhouse gas emissions. And really, I've talked mostly about batteries, but there are a lot of other things that scientists have been doing to try and tackle this issue. But you may be wondering what a few things you can do in like your own home to try and reduce your carbon footprint. So I've listed out a few here. As we've discussed, agriculture is a large part of greenhouse gas emissions. So reducing our reliance on agriculture by eating less meat is one good way to do that. We can reduce our reliance on transportation by using public transportation, biking or walking whenever we can. Recycling and composting food waste is a great way to reduce the amount of waste we're putting into landfills. When shopping, we're bringing a reusable bag rather than the plastic bags they provide there, and then buying food locally so that the food doesn't have to travel really far to get to you is another great way of doing it. And then turning off the lights in rooms where you're not being used so we can reduce our reliance on electricity in general. But I'd like to thank you for listening, and then now open it up for any questions.
All right, so I forgot to mention at the beginning, if you do have any questions, go ahead and ask them in the Q&A section. But to give y'all a couple minutes to come up with some good ones, Lauren, I had a couple questions. Well, I guess it's kind of a two-part. So in the meantime, like until batteries do last long enough that there is like practical application in these large technologies, how are they kind of working around that to be green and be sustainable? Like, are they combining these different technologies?
Yeah, so like hybrid vehicles are, I guess, an example of combining the current technology with the lithium ion battery technology that we currently have. And so you have in those vehicles, you have a combustion engine and you also have a lithium ion battery, so that you can rely on both and you get the range that you need, and the issue with charge time is alleviated, because if you need to travel further, you don't have to charge your car, you can fuel it on oil. but you can also try and be greener whenever you can by relying on that battery. And so I think that, and I mean, people are working on just tweaking kind of lithium ion batteries, trying different electrodes within that electrochemical system. And you're able to get slightly higher capacities out of that if you're able to have electrodes that work similarly, but are able to shuttle more charge per formula unit.
So I have actually two questions. My first question is actually a personal one because I wanted to make sure I was understanding and following. So pretty much we have like several different ways that we can produce energy, that like from like coal to wind energy to water, things like that. And but all of them have their like advantages and disadvantages. So you're saying that an advantage would be like if we were able to create batteries that will like hold these charges of like sustainable energy, such as like solar energy and like wind energy and things like that. And so you were talking about like creating batteries. So are you saying like in your lab you're creating like batteries that are able to like hold the this like excess energy just in case we have like a cloudy day and we can't receive that much like solar energy that day? Is that what you're saying?
Yeah, so that's the end goal. My lab is a materials chemistry lab. So we make materials that are similarly layered to the lithium ion battery materials, but could be applied in a fluoride ion battery. And fluoride ion batteries have higher capacity, so they could store more energy than lithium ion batteries can. And so if you're able to make batteries that can store more energy, you're able to store more energy for any of these applications, which is kind of a problem with renewable sources in general, is that you're not able to get most of them are not constant sources of energy. So you need a way to store a lot of energy for times when you don't have the source.
Gotcha. Okay, I was just making sure I was following correctly. So thanks for catching me up. But I think Riley has a question that she wants to ask.
All right, so we have one. Do lithium ion batteries require rare earth metals?
So the commercial ones currently do not, because they're only made out of lithium ions. They're made out of graphite, which is carbon, and then they're made out of cobalt oxide. But there are lots of different types of lithium ion batteries, even some that are commercialized that maybe just don't necessarily work as well as the cobalt oxide lithium ion batteries that I discussed, that are made out of rare earth metals.
All right, and we have another question from McKenna. Do you think using hydrogen fuel cells in cars is feasible or have any place in the, hold on, my question went away, in the car industry in the future?
So I know very little about hydrogen fuel cell cars. I know that I've seen a lot of papers coming out about it, in my time. So I'm a second year, so I've been really deep in science in 2 years. And even in my 2 years, I've seen a lot of papers coming out about it. So there's definitely a lot of money and resources going into that type of research. So it seems like it's possible that is an avenue that people are looking towards. But I've definitely been more focused on the electric vehicle aspect of trying to reduce transportation emissions.
All right.
All right, so there's another question from the group. Shiny wants to know, what are your thoughts on nuclear energy? Is there any method being developed to store radioactive waste?
So my thoughts on nuclear energy, that's kind of a loaded question, but I think like it can be good. But we have to do a lot more research on finding things like places to store radioactive waste. And that's really an avenue that we need to explore more before we scale up the amount of nuclear energy that we're relying on. I don't think I want to speak too much more about it because I'm really not educated in that area too in depth. So.
Well, I have one question. Until the batteries become a viable option, and if just in a perfect world, what do you think would be the best way to harness energy now? Like with the technology we have, if we could just like snap our fingers and have that technology implemented everywhere, what do you think would be the best?
With the technology we have now,
Yes.
I think it's got to be a combination of things because, again, there are disadvantages to all of the methods that we have, and they're not like small disadvantages, like they're pretty large reasons why we can't scale up or we can't use the energy in everywhere. Some of them being cost and some of them being other things. But I think, yeah, I think it's really got to be a combination of things. I don't love the idea of using a lot of biomass because I think that that is still not a really clean way of producing energy. But I think a combination of using wind energy where we can, because again, wind turbines are pretty disruptive to communities in which they're installed. And so maybe like even installing those more out in the ocean. But again, there are other complications that I probably don't know about with that. Solar cells are that technology is rapidly improving, and there are a lot of people at UNC that I know are studying materials related to solar cells. And I think within the next 5 to 10 years, we're going to see a lot of improvement there. And I think soon that those will be very accessible for people. So I think solar energy is really the place where I think we're headed in terms of trying to power buildings and yeah, but
Okay.
making electricity.
Thank you. So I think that's about all the time we have. So Lauren, thank you so much for joining us, and everybody who tuned in, thanks for joining. Next week will be Alex Niebergall. She'll be talking about how ocean currents can influence climate and the ways that scientists can measure that. So be sure to tune in 5 o'clock Thursday, and we'll see you then.